Salam sejahtera and good evening. Today we're going to have a very short video talking about the equilibrium of rigid body. A simple one. We have a 2D system. I have a beam supported at A with a pin and supported at B with the roller cam, and we apply a force of 4 kN, 6 meter from A and 2 meter from B. So the question asking you find the reaction at A and B. This is very simple question. Again, number one to do when you have the equilibrium of rigid body, summation of force is 0, summation of moment is 0. But before that, you must draw the FBD correctly. So the FBD for this beam. So again, guys, when you draw the FBD, only draw the beam. You do not redraw the pin and the roller. So draw whatever that given to you roughly, or you can even draw a line. You don't have to draw a box. You can even draw a line just like that. That's fine. And then you put whatever force given there. Put force, the direction correct, and then put the value there. Put even with the units. And then you label the point here as A, point here as a B, and then put dimension. Where is the force being applied? So whatever dimension given, put back over there. This is 6 meter, and this is 2 meter. And at point A, you know, it's a pin. Pin, the reaction force and pin always on. It doesn't allow the beam to move X, doesn't allow the move on the Y direction. So the reaction there is only X and Y. But it can spin because the pin allows it to spin. So there is no moment reaction at point A. So if you don't know the reaction, what the reaction of the reaction at A, just simply put this is the reaction. Let's say this is the A. Just but before that, always make a habit, define your axis. This is the X positive, this is the Y positive. So just simply use the positive for the AX and the positive reaction for the A. Y. But here, you know, a roller, there's only one reaction. So the reaction is always perpendicular to the surface. Always perpendicular to the surface. Yeah. So the reaction here is only this direction with the angle of 30 degrees. But again, for the roller landing, you cannot assume the arrow to be down. You must be very clear, because in this roller, the beam cannot move down. That means the reaction is opposing the force. So the reaction can only be upward. But if you put the force here, the beam can be lifted from the ground. So that means there is nothing to stop the beam from going up. That means there is no reaction. So the only useful of this roller is it cannot move down or cannot move into the direction of the incline. But that's why when it comes to roller, you must be very clear how to define the direction of the reaction. It always again the motion. Imagine that this is the ground. So and then the beam cannot move down because there is a reaction opposing it. But if you change the force here from here to up, of course the beam can be lifted. But here you don't know, because it can be the pin doesn't allow the beam to move to the right, doesn't allow the beam to move to the left, up and down, so it can be either way. So just simply put the positive value of the X and AY. So when you do that, then you start doing the summation of, always, in many cases, we always start with the summation of moment, because in many cases it gives you the answer straight away. So moment at point, you can choose any point. You can choose point A, point B, because of this situation, the moment at A and the moment at B is always 0. So if you choose the moment at A is equal to 0, so because it's 2D, you can use the diagram approach. So you assume that it's a counterclockwise is positive. So having that one by one, do not look here, look at here. So look at the force 4 kilonewtons downward. The distance is 6. times 4. But because it's turning clockwise, it becomes negative. And this force here, the distance A to B plus 8 times the reaction, you call it, let's say, this reaction B, or you simply put B times B. So if you resolve the force into the X, Y, and X, so the only force that creates moment is the Y component of the B. Y component of the B is B cos 30 degree. The component of X are the B reaction, because it's aligned with the point of A, giving no moment, so there is no moment by the X component of the reaction at B. So all become 0. So from here, the only unknown is B. So straight away you can get the value that the B is equal to, I can see, 3.46 kilonewton. So we have got the value of the B, reaction at B. Now we need to determine what's the X and AY. Of course, again, summation of force, X is equal to 0. We define the positive to the right. So AX minus B sine 30 is equal to 0. Then we get the AX is equal to 3.46 times 0.5. So AX is equal to, let me see the value, 1.73 kilonewton. Guys, I will recommend you, whenever you get the answer, try to box your answer. So I can, when I do the marking on you, so I can straight away find the answer. So I can quickly mark yours. So all the job can be done. And then if you have a wrong answer, I'll go back to your solution, how you come to the equation that made you a wrong answer. But if you got the right answer, so it's easy for me to determine which one is the answer. Okay. And then summation of force Y is equal to 0. Define it, the Y positive is upward. Then we know that the AY minus 4 plus, this is upwards, B is 3.46 times cos, what I'm doing here, cos 30 degree. Then we get the AY is equal to 1.0 kilonewton. That's it. Thank you for listening. See you again in the next video. Assalamualaikum and good evening.